2 years ago, at this event, Microsoft announced a new platform called Microsoft Fabric. At that time, it was called the Unified Analytic Platform for Data. Even back then, in the databases team, we saw an opportunity to unite data in a way that's never seen before. Because in the databases team, we're all about data. And so last November, we announced the public preview of SQL database in Fabric. Hello, everyone. I'm Bob Ward, a principal architect in the Azure Data Team for Microsoft. So excited to be back here at Build again today, and also joined by my colleague, Anitha. Anitha, I think your team announced something at this event.
Absolutely, Bob. Hi, everyone. It's wonderful to be here with you all. Thank you for taking this afternoon to spend with us. We announced Cosmos DB in Fabric on Monday here. It's in preview, and I'm excited to share all the details on this. And everyone joining online, please stay tuned.
Wait a minute, so SQL and Cosmos now together in the same fabric. I kind of like the feeling that both databases, right?
Yeah.
So that's what we're going to do today. We're going to tell you a little bit of some foundations of why we did this. Anita's going to spend some great time diving into about Cosmos DB, what's that experience like in Fabric with some really cool demos. I'll come back and show you that SQL experience, and I think we'll unite forces at the end of this session together to show what's possible with the Microsoft Fabric. Hey, some logistics for you. You want the deck? All the demos are in the deck. Do you see that site right there? aka.ms, bobwardms. In there's a folder that says Microsoft Build 25, and this entire PowerPoint deck is in there with all the demos. We are open source presenters, so you take this deck and use it to your needs. We want you to spread the word about what we're doing. We know you're going to have questions. We got a lot of stuff to cover. So at the end of this session, we will be available afterwards to talk to you and answer all those great questions. But we have an army of experts at the booth at Microsoft that can also talk to you about these things. So to get started a little bit, maybe you've seen this message a lot. It makes sense. Data and AI have to go together. You can't have AI without data. And of course, we're in the databases team, so we're all about that. And the Fabric brings a unique experience as a developer now to bring these forces together in an incredibly unique way. I told you before, 2 years ago when Fabric got announced, it was called the Unified Analytics Platform for AI. Look at that change, the Unified Data Platform for AI. And if you think about all those icons you see down there, it is the integration story that is the true value. I think you're going to find out today of the why part, like why would Cosmos DB and SQL be part of the story? It is about that deep integration you're going to see. We have some really cool demos to prove it to you. And you see in the middle there that purple icon called databases. Now operational databases that you know and love and trust, both from Azure Cosmos DB and SQL now, are now part of this incredible story. So what I'd like to do is turn over to Anitha now to talk a little bit more about what is the value of why and how databases are part of this, the developer story, and dive right into Cosmos. Anitha, take it away.
Thank you so much, Bob. So with the innovation that we are seeing in the AI space, the apps that we're building are changing rapidly. Satya made a lot of good announcements for AI on Monday here in the keynote. And you can see that the AI agents are really transforming on how we think about apps. They're getting more task-oriented. They're getting more autonomous. And when we think of how data gets used in these apps, that's going to be significantly different from the traditional apps. For example, today in your traditional apps, all of your organizations may be spending a lot of time on how you configure your databases, how you set up the scale, BCTR, backups, and so on. But as you look into AI apps, developers like yourself, you may be wanting to focus on training the models, or improving the prompts, or just getting better outcomes out of your AI apps. You probably wouldn't want to be bothered with all the overhead of managing data. And so to make it simpler for you, to help you build AI apps easily, we are introducing Fabric databases. That's what we announced last fall. And we're building these databases with 3 principles. The same databases that you see in Azure, but built differently to make it simpler for your application development. Number 1, these databases are going to be simple. It means that you will give the database a name and can get started from your apps anywhere. So imagine being in an agent app and you're trying to store data, and if you have to remember all of the settings that you're today configuring in Azure, wouldn't that be too much of a chore? So we are making it super easy for you to get started. Number two, we're going to make it autonomous, which means that not only can you provision these databases with just a name, we are choosing the right defaults for you, whether that's indexing policies or backups and all other complex security and scale settings. We're going to get started the right way. And finally, we are optimizing our databases and giving AI features in these databases for Fabric, the same features as what you have in Azure. But the great part about Fabric databases is that this data is going to be automatically available in OneLake. Now, with the power of OneLake, you can take all of the AI features and all of your data with the unified data estate and can achieve so much more for your applications. Now, Bob talked about Fabric being a unified data platform. But did you all know that it's also a very well-equipped, integrated AI application platform? All of your data in the data layer from OneLake to databases work really well with developer tools. You can use VS Code extensions for this data. You can use Fabric CLI. Some of you don't like using UX for Fabric, and that's OK. You can use Fabric CLI to interact with your Fabric items. Terraform and GitHub for CI/CD and source control. Now, Fabric has a lot of business logic built in directly into Fabric. You have user data functions right there for custom business logic, so you don't have to go to Azure to write functions. You get the API for GraphQL right there. So if you have different data, like SQL, Cosmos DB, you don't have to learn the query language for each of these. You can build a common GraphQL API surface. And the announcement that really caught my interest in recent times, data agents in Fabric, I'm really excited about this feature. It lets you do conversational insights on your data layer in Fabric right within the Fabric ecosystem. Now, beyond the built-in features, Fabric beautifully integrates with all of the Azure services today that you use for your applications, like container apps, app services, API management, and whereof all your AI action is happening now, that is Azure AI Foundry. Whether that's through data agents or through direct integrations, you can access Fabric data through AI Foundry for your applications. Now, switching gears, we're going to talk about the announcement that we talked earlier, which is Cosmos DB in Fabric. I'm going to talk about Cosmos DB in Azure for a bit, and we'll see how this spans into Fabric. Azure Cosmos DB is loved and trusted by a lot of you. You use it actively for mission-critical workloads. In a recent survey, 26% of the CIOs opted for Cosmos DB as the default choice for their AI workloads. With instant auto-scale, Cosmos DB provides elasticity that you need for your AI workloads. It's a highly performant database, allowing millisecond reads and writes. And it provides 5 nines availability for your mission-critical workloads. OpenAI runs on Cosmos DB for all of their ChatGPT sessions. That's how scalable it is. Cosmos DB is built in with a number of AI features, such as vector search, full text search, hybrid text search, and disk ANN. We'll talk about these features in future, but all of these capabilities make it a default choice for your AI workloads. Now, we are bringing all of this goodness of Azure, Cosmos DB, into Fabric as Cosmos DB in Microsoft Fabric. This is now in preview, and it's powered by the same Azure Cosmos DB that you know and love, the scalability, availability, reliability, but we are making it easier for you to build your apps. When you're building agentic AI apps, again, building on the principles of Fabric databases, we are giving you a database that is simple, no complex settings required to set it up, autonomous, just works out of the box, and optimized for AI, has all the hooks and whistles that you need to get started for AI for your applications and get most of your data. Now, all of the data in Cosmos DB is automatically made available in Fabric OneLake. And so all of the Fabric platform with all of its goodness for data scientists and data engineers, also opens up to Cosmos DB. And if you are having apps that have relational data and some unstructured data, now you have SQL DB and Cosmos DB available in one place, that is Microsoft Fabric. So let's talk about the principles on which we build this Cosmos DB in Fabric. First, as we promised, it is super simple. You give it a name, and it deploys in seconds. You don't have to worry about subscriptions and accounts and all other complex settings that today you fill in Azure, about 5-6 pages of it. All of these are configured for you right out of the bat. Now, the scaling is automatic, which means that the database just works. You don't have to specify the request units either in the UX or through SDKs. Now, you may be saying, hey, how is that going to work? I really sit and tweak my numbers, and I really like to scale it for my high ingestion load, and I really don't like this automatic scaling. And if you're one of them, we heard you. We are going to give you an escape hatch just in case. So if you have those scenarios, you can go and tweak the scale settings, but by default, you won't need to handle scale at all. If you are just getting started with Cosmos DB, you don't need to know it. It's also a secure by default database, which means that it's automatically configured for network security. Tenant-level private endpoints work right out of the bat, and we are also working on providing workspace private endpoints in future. The authentication to these databases is through Entra IDs. Now, we don't support account keys, so it's easier to manage that way. If you're a logged-in user to Fabric, you get access to the Fabric with the role permissions that you have there. Once you have deployed the Cosmos DB, you can see the familiar Data Explorer. So if you are an Azure customer coming into Fabric, same look and feel, no ramp-up time. You can upload the data through JSON files or through bulk inserts in SDK. You can also query this data with the familiar SQL that you have in Azure. Now, the queries that run within this tool that we call Data Explorer, they run against Azure, so they will have consumption units. So consumption units is a scaling aspect. Like when you actually use Cosmos DB, it gets charged as consumption units, and these consumption units are accounted for your capacity. So when you query, when you're doing reads and writes, those all accrue towards consumption. Next, we're going to talk about how you can connect your apps. So in Fabric, every database gets an endpoint, and you can get this endpoint in the settings under connection. So you can use this endpoint in place of account endpoint when you're using Cosmos DB client in the SDKs. All of the popular SDKs will work as is without any changes. So you can use any of the existing apps that you have, and using Entra as authentication, point them towards Fabric database. Now, the authentication, we talked of Entra, but you may say, hey, I have an app, and I don't want to work on user-based or Entra IDs. If you have those requirements, we do support service principals as well. So you can create a service principal, assign that to your app, and have the service principal on the Fabric workspace and get access to the workspace. Now, we don't have account keys, as I said. We are doing it for your security, so you don't have to worry about rotating account keys and leaking keys and so on and so forth. It also means that the clients, so now you take Visual Studio Code extension or Logic apps or Azure functions, some of these have Entra support. Wherever the clients have Entra support, they'll work out of the box with Fabric database as well with no changes. But a lot of our clients also are based on account keys today. And so some of these may not work for time being, and we are working on addressing those gaps as we go. So we talked about AI, and we talked about AI features in Azure Cosmos DB. So let's take a look at these in a bit more depth. First, we support built-in vector indexing and search. With this capability, you can get similarity search on your data. For example, tell me all the products that are similar to this product. We also support full text and hybrid search. What it means is, if you have a lot of text and you want to get insights on this text, now we allow you to search through all of the data with just keywords. For example, give me all the products of this brand, right? You can also do hybrid search, which means you can do semantic plus keyword-based search. So it's a mix of the typical semantic search and the full text search, and that's why the name hybrid search. One example could be, hey, give me all the products that fit this criteria. So maybe give me all the products that have shoes that are comfortable to walk in, and then that belong to this brand, which is your keyword. And then we also support DiskKNN, which is a capability for larger vector indexing. So if you have a lot of data that doesn't fit into memory, you can also take the help of DiskKNN to index this data. All of the AI capabilities that are landing in Azure Cosmos DB also land into Microsoft Fabric. Now, the key aspect of this database is that it is fully integrated into Fabric through OneLake. As you add data, you don't have to do anything. The data automatically gets replicated into OneLake in Delta Parquet format. Once the data is in Fabric, you can use it downstream for all of the tools in Fabric, such as notebooks, ML, BI with Copilot, or data agents. As I said, it's my favorite feature, so please do try it out. Now, you can also take this data and make it a shortcut in Lakehouse. And through Lakehouse, now you're getting mirroring data, shortcuts from other clouds, other sources. You now have an entire data estate that can work with your Cosmos DB data as well. You can join SQL DB data with Cosmos DB data. That's not possible in Azure without a significant legwork, right? So it's very easy to do this within Fabric. You don't need ETL pipelines. You don't need to put a lot of systems together to get disjoint or disconnected data systems working together. Now, the key benefit of this is that you get insights across all your data. No matter where they are, you are able to look up insights and draw inferences, which may improve your business, right? So I want to draw your attention to how seamless it is to access your databases, whether that's on operational side or on analytical side. So you're bringing a lot of SQL databases, Cosmos DB databases into Fabric. So on operational side, you can create an API interface for these databases through GraphQL. And on the analytical side, you can do this with OneLake data. It forms a single unified way to do T-SQL queries or any of the downstream data. So on both sides, one platform, one easy way to get to your data. And so you can build apps as well as you can get benefit all the way to analytics in the BI side. So now I'm going to show you a quick demo of how Cosmos DB works in Fabric. So we're going to talk about a scenario. This is a retail scenario. AdventureWorks is a retail customer, and they want to build an AI shopping assistant. With the shopping assistant, they want to provide contextual product responses. And once they've done building the shopping assistant, since they're getting a lot of questions about products, they thought, hey, we get to know a lot about products and how customers think about our products. So can we get some sentiment analysis on this chat history? And with that sentiment analysis, they can figure out whether the customers like the products and how they're perceiving those products in terms of price and other characteristics. And they then wanted to take it forward and get some product recommendations. Now they have all the products, let's say in Fabric. They can use the data science in Fabric to figure out the recommendations that they need to generate. And so let's see how they build that. You're on retail websites, you're browsing for products, you always see, hey, do you want to buy these products? They look similar to what you're looking for. It's that system that they want to build. And finally, we'll look at how they got insights across their data estate. All right, here in the AdventureWorks website, we have a customer looking for snowboards, and they're struggling to find what they're looking for. So they go to the shopping assistant agent, and they're asking the agent that they are advanced in their skills, and they're not finding a snowboard that they're looking for. And they posted this question, and as you can see, the shopping assistant recommended a product to them. And it described the product, but the cool part is that it also gave a lot of recommendations that are similar to the product that they're looking for. So this response is contextual, relevant, and gives the customer all the options they need to look for the snowboard that they want. Now let's see how they build this shopping assistant with Fabric and Cosmos DB in the background. So to build the shopping assistant, here we have the customer asking the assistant a question. Now, this picture could be complicated, so I want you to focus on one where the AdventureWorks uploaded product catalog into a Cosmos DB database in Fabric. Now, this product catalog is being used in user data function in Fabric, and they're doing a vector search on the product catalog to find similar products. And then they're going to send this to OpenAI to generate LLM response, like the response that you saw earlier, which is contextualized and conversational as well. So the context of the products coming from Cosmos DB and LLM response coming from OpenAI. And before returning it to Shopping Assistant, they're going to store this data in chat history collection in Cosmos DB again. So let's see how they made it happen. So here in Fabric, in the workspace, we can create a Cosmos DB database by choosing Cosmos DB and giving this Cosmos DB a name. As we promised, super simple to get started, just a name. And deployment is done in seconds. No more pages of configuration built by default to work. And here we can see the Fabric database endpoint that you can use for SDK and clients. And now they're going to create a container for product catalog. And again, creating a container is super simple, just a partition key is required. And they're going to upload the product information as a sample JSON file. They can also upload through SDK. So you can see all of the unstructured data right here from the Data Explorer. You can query using SQL, and these are running on Azure Cosmos DB in the background. And they're going to create a new container for chat history. Now, we won't fill this container yet because the data actually comes from the user data function. Okay, so we created a chat history container, and we're going to leave it like that. And now we're going to move to the user data function. It's in Fabric. Okay, so they're getting the question that the shopping assistant is getting. So you see that they're getting that request, and they're generating a chat response. To generate the chat response, they pass the question as a body to vector search in Cosmos DB to get related products. Once they got the related products, they sent it to LLM to get the AI response from OpenAI and stored it in Cosmos DB chat history container that we just created. Okay, so now we are going to publish this function. We're going to take the URL of this function, and we're going to have the shopping assistant copy this URL and invoke this URL, right? So it's invoking the user data function. For every question the shopping assistant gets, it's invoking the user data function. And as the responses are getting generated, new items are getting inserted here into chat history collection. So you can see all the question and answers and the products right here in the Cosmos DB collection that we just created. So it's as simple as that to get the shopping assistant going. They were thrilled to see how easy it is. But the real power of Fabric comes from data science and BI, taking beyond even the operational use cases, right? So the data is now available in OneLake, so they're thinking, hey, we can use it to get further with our data. They want to do sentiment analysis on this data to find which of their products are well received and what are the characteristics of these products, and then build a BI report to get some more insights. To do that, here they are in a Spark data frame. They loaded the mirror data from Cosmos DB in Fabric into the Spark data frame. And from here, they are using Synapse ML library, calling Azure OpenAI with this contextual data, so with the product catalog data. They are looking at patterns, and they're trying to find, in the questions that customers are sending, what features do they like? What features do they not like? How is the sentiment of these messages? And what are they saying about the product characteristics? For example, the price, the size, usability, and so on. So now that they have done some consolidation, and I'm not showing the full notebook there, now that they've done the consolidation, you can see the BI report where they are now able to figure out liked and disliked products by brand and other characteristics, all coming in real time as the data is landing into Cosmos DB. Now they're thrilled on how easy it was to achieve those two scenarios. Now, without Fabric, they would have built a lot of ETL pipelines and put together many different services to pull those two scenarios to happen. But it was super easy and convenient in Fabric. So now they want to go to the next scenario, which is they want to give product recommendations. As I mentioned, you're in a retail website, you're looking at a product, and you want to give, you want to show what all other products are related, so customers maybe may have those options to buy, right? So here on their website, this is what they want to build. On the right side, you can see the related products to this snowboard that we're seeing on the left. And to build this, they are going to have vector search done again on product catalog. So here, now we're in the notebook in Fabric. So we're not starting with the database, but rather just a notebook. We did the vector search in product catalog, and we're going to take that output and store it into Cosmos DB, a new Cosmos DB recommendations DB that they created, where for a given product and user, from the notebook they got the recommendations. Now they're writing a user data function to call this database. So there's a query here, as you can see in the function. They're querying for the data, and from the app, they're invoking this function. Okay, so that's how they are able to really get the data from Cosmos DB for low latency serving, right? So if there's no Cosmos DB, you cannot give this data at the scale that the customers may be browsing the shopping website. And we call that scenario reverse ETL, by the way. Again, doing reverse ETL without something as integrated as Fabric is a very tough thing to do. Typically, organizations like yourselves may find investing months into building different services and building a system like that. So it is super easy and convenient to do this in Fabric. Finally, now with all the data there, they're going to get some insights across Cosmos DB and SQL DB. So they pulled all of their orders data from Azure Cosmos DB into Fabric. Now all of this is getting into OneLake as well. So now they're going to take this data into OneLake and join that with SQL. So here in SQL endpoint, where the OneLake data is there, we can see the orders tables, and we're going to pull the store sales information from SQL DB. And with the SQL data also available alongside Cosmos DB, now they can just write a query putting Cosmos and SQL together and get data insights across all of their data estates. Now, if you see the query, it's as simple as that, just referencing the table names to put together a unified data estate query. So to conclude, we are making it super easy to build apps with Cosmos DB in Fabric. It has all the AI-ready features that you need, as well as the scalability, reliability, and availability of Azure Cosmos DB. And it provides deep integration to power your apps with Fabric ecosystem. You can start with operational and move seamlessly to analytical and BI, or start with the notebooks, the data science, and have the data added to the operational, as we saw in the reverse ETL scenario. And this preview is today available for limited participation. For just about next month or so, we're going to allow only select users to try it before we go wider preview. So there's a form to sign up for this. So here's the link, and you can sign up. Thank you so much. And so Bob, can you talk about SQL DB?
I can, but that was pretty amazing. Good job. That was awesome, Anita. Thank you very much. That was great. I love how Anita nailed this theme of simple, autonomous, optimized for AI. Because guess what? We have that same theme. Anita, I'm going to go through some SQL stuff, but I'm going to bring you back so we can tie this together at the end. So if you think about what she just showed you, in SQL, the same things exist. Deploy in seconds, easy editor experiences, all integrated, easy way to get GraphQL connected to your database, SQL endpoints that you know and trust. But autonomous because we took all the power, notice at the bottom down there, security, performance, and availability of Azure SQL. Everything you're used to as a developer are woven and built into this. So all that great auto backups, auto HADR, all that functionality is in SQL Database and Fabric. This is not a different engine. This is the SQL Server engine you know, but woven into that Fabric experience and definitely optimized for AI. The same type of functionality of vector support, AI assistant support, connected to Foundry. You'll see all of that a little bit later as I go into the details here. So what does simple mean? So if you've ever deployed Azure SQL Database today, it could be pretty fast actually, but how'd you like to deploy in seconds? Like give it a name, no knobs, no configuration required. You just get an auto-scaled serverless database running in the context of Fabric. But know this, the database behind the scenes is still the database you know. It's still a transaction log and a database file and all that stuff behind the scenes to power operational databases. So easy provisioning, great editor experience. I love, and I'll show you in a demo in a second what that actually looks like. Copilot to help you build SQL queries. A rich Copilot even inlined inside the editor. And then of course, it's all based on T-SQL. So we know that's a language you need as a SQL developer, so that's all woven in. It's the same SQL language you already know. Then you need to have application lifecycle management. That's actually built into Fabric. Because it's in the Fabric workspace and SQL is part of that, you can take advantage of that. So if you need complete source control through Azure DevOps or GitHub, that's all built in. So as you build databases, scripts, all those types of things, all your objects now become part of that rich project system that you could yourself do as well in Azure DevOps or in GitHub. So that's built in to the entire Fabric editing experience in the portal. And then finally, this is really important. Anita talked about how Cosmos DB is integrated with Fabric with OneLake. Well, SQL is the same way. Imagine you need to take a read-only version of your data and be able to access it to kind of like offload read queries. You can do that because it's automatically replicated and mirrored in OneLake. You know, we announced SQL Server on premises can be mirrored into OneLake at this event. SQL 16, 22, 25. In Fabric, it automatically happens. So imagine using an operational database. As soon as you deploy it, everything behind the scenes is now being mirrored for you into the OneLake system with Delta Parquet files. And now you can use something called the SQL Analytic Endpoint as a separate connection to get access at near real time of a read copy of your SQL database. That is extremely powerful. You're going to see in a demonstration how we're going to make that powerful to make sure we don't affect an operational workload with that. So let's see a demo. Let's just see a quick demo of what this simple experience actually looks like. So here, I have deployed a database inside Fabric, similar to what Anita showed you for Cosmos DB, and I'm just going to give it a name. And I said behind the scenes now is going to be a serverless auto-scaled database. In the Fabric editor, I'm just running T-SQL to go build like an insurance database. And I've got this really nifty Explorer interface that kind of looks like what I'm used to in like Management Studio, to kind of see what my objects look like. So what I'd like to do is run a query. I don't know about you, but I'm kind of a lazy programmer. So why don't I use Copilot to go do that? So I'm going to go here and just give it information. It knows my schema. So it can help me do joins. I don't know about you, but I don't remember all the key relationships. So just help me build the join. It does. In the sidecar chat, I can click, put it in the editor for me, and I can start running away. What I love, though, this experience is to help me with query problems. So if I have a syntax error and I forgot what the problem is, I can just fix query editors in line. Or maybe I need to document my query with like comments inside the join and things that I'm doing. So I can explain to get that rich experience to go do that. Now, as a developer, you can connect with a SQL endpoint and use SQL provider code, or you can use the GraphQL support. So Data API Builder built inside the covers. So easily now, you can go and set up APIs for GraphQL to go connect to this database to make development a lot easier for databases. Pretty powerful stuff. And then I mentioned about source control, no problem. Over here, I've made changes to my database, so I've automatically got source control built in inside that Fabric UI experience to go push and commit and do PRs inside my repo that I have for this actual database project. Pretty nice. Now, I mentioned about replication into OneLake earlier. What does that really look like? So here's a query that I took that I just did on my operational database. What if I could take that same query and run it against the analytic endpoint? So here in the editor, I can simply switch to that. Instead of using the actual SQL operational database, I'm actually using this read-only version of it. So I can click that. I can just copy the query. There's also a Copilot experience, by the way, in the analytic endpoint if I want to. But I could just copy this query. I've got the same tables mirrored there. So I can copy the query, run it. I'm going to get the exact same results. This is beautiful as a developer because now you have this great power of using your normal operational database, but even setting up new read workload scenarios against this mirror and then go and not affecting your operational database itself. So that's just a taste of what it's like to get started. For fans that like Visual Studio Code, fans that like SSMS, they also work against this. If you don't want to use the Fabric editor experience, you can use naturally those tools you know and love already. Okay, so what about autonomous? What do we really mean by that? So just like Juanita talked about Cosmos, secure by default. So you've got Entra built into it automatically with no configuration, all the great SQL security you love, all the auto-managed HADR. Wouldn't I love to just not worry about that? I don't worry about backups. I don't worry about failovers. All that configuration that you normally do on-prem is all built inside the service because behind the scenes we're using Azure SQL to make that happen. In fact, look at this list. These are all the goodness that you get from using Azure SQL database today, and now inside Fabric, even though you're deeply integrated in that Fabric environment, behind the scenes you get all of that, including not just HADR, but things like auto-indexing. And you get intelligent query processing built in the query processor. You get to take advantage of all the innovation we put in Azure and in SQL Server, and you get it in Fabric. So if you're worried about like, oh, I'm going to go build applications with SQL, database, and Fabric, I'm sure it's not really related to what's going on in the rest of the SQL world. No. We have this philosophy, ground to cloud to Fabric. We want SQL to be a consistent experience for you, but in Fabric, it's going to be a little different, right? Simple, more integrated and autonomous than you might be if you're running in, say, Azure SQL or SQL Server. So I love all the automation that you get as part of this. Now, what about optimize for AI? So a little bit like what you saw from Nita talking about Cosmos DB, you may have seen us announce at the public preview for SQL Server 2025 this week that we're now a vector store inside SQL itself. It's the same engine. So we have that same vector store built-in capabilities now in Azure SQL and inside SQL Database and Fabric. So if vector searching is something you need to provide for your application, smarter searching, you get that now inside SQL. And as part of that, we've built in a very nice, simple integration with Azure AI Founder. You'll see in a demonstration in a second how easy it can be to do that. And it's all secure and scalable. So one of the biggest things customers talk to me they're worried about AI is security and privacy. Imagine using the power of all the great security you get with SQL, and you saw it with SQL Server 2025 in our announcements, you get that with SQL Database and Fabric. Every access to doing anything with AI in the engine is using the same security model that you're used to seeing in SQL today. And Copilot experiences, you saw already, Copilot inside the editor for the Fabric experience, Copilot in the analytic endpoint, and then if you're using SSMS, if you didn't see that announcement, a Copilot now in Management Studio, the new version in 2021. So I thought it would be interesting to look at an example. We could show just maybe some vector searching, we could show pieces of it, but why not put it together in form of an actual real-world example with agentic AI and to show the deep integration. So consider this customer, this company called Contosa Insurance. They have two challenges. Their customers can't find their claims very easily. Imagine like a corporate customer for insurance, like corporate insurance, company insurance. They've got like maybe thousands of claims they're dealing with. And so they're trying to go figure out where all these claims are. They can't find them. And number two, they're struggling sometimes when they need to appeal a claim that got denied. So the insurance company behind the scenes is struggling as well. because they can't handle the input of all of this. The process to help them find claims was manual. The process to go process these claims was manual as well. So it requires a lot of data integration to make this as possible. Now, the other thing is the company, this Contoso Insurance Company, would like to kind of look at AI as an option. They don't want AI to automate things. They want AI to assist them. So I'm thinking to myself, if they use a SQL database as part of the solution, maybe this could be something we could do to help them. So how do we do it? So consider this architecture diagram, and we're going to go through each of these pieces. So number one, we already said if we have a claims database, we're already mirrored into OneLake. Secured and governed by Purview and Entra ID authentication built in. So consider that all this claim data is mirrored already. That's going to become important in a second. So the first thing we're going to do is use this new built-in vector support to generate embeddings with an embedding model in Azure AI Foundry and store them inside the database. Why? Because it's going to power a new app we're going to build to allow a customer to search their claims using vector searching and powers an operational RAG app using a chat model. So now I've got this app now that gives customers this better searching experience. What's next? If a customer decides that they need help or review a claim, that claim review could be pushed into the database. We can now use real-time intelligence with event streaming to process this asynchronously behind the scenes. What happens then is we can actually write data science code to process from the event stream, take this claim review data, look up other data in OneLake, not affecting the operational database, and feed that into an AI agent. The AI agent can take that as input with other tools and provide a recommendation. That recommendation gets written back into OneLake. Why is that important? The guy in the cubes will love this. Power BI. I can write a Power BI report on top of OneLake now with all that data and help this claims officer process and get recommendations to do it faster. So faster lookup, faster recommendations. Let's look at it all together. So first of all, let's look at the embedding piece. I'm using the new interface in T-SQL to define an embedding model in Azure Foundry to go connect with to generate embeddings. I'm using T-SQL here. This syntax has slightly been updated a little bit since we just launched SQL 25 to generate embeddings from the model and put it in a native vector type. And then I'm going to build a vector index on top of that. What do I do now? I do vector searching. So I'll build a stored procedure for that chat app to go take a prompt, a natural language prompt, and feed it into a vector search. Do you notice in this prompt here it says show claims where an accident occurred? Do you see the word accident anywhere in the description? It's not. But a natural language model knows that word accident can mean similar results to what happens. Here are all the different claims in my small little sample. I've got only 4 claims. But notice only 3 came back. Because 3 of them are related to an accident, the other one is not. Because natural language searching with vector searching gives me those similar results. So now, instead of having to rely just on keyword searching, which you could combine with this, or using like clauses and so forth, you can use the power of vector searching built into the engine, all secured by SQL Server to power an app. Well, what I decided to do was to go over in Azure AI Foundry into the studio and play around with a proof of concept for that app. So in here, I'm going to provide some system instructions. You may have seen this kind of concept before, to a model. I'm using GTP 4.0 in this case. Like, here's how you need to behave. In this application, you help people find claims. And I'm going to feed you some data. And SQL is going to be that data source. So the app can then take a prompt like this. Show me claims related to an accident. Just like that stored procedure, the app is going to call the proc. The proc is going to come back and, based on my system instruction, format these results really nicely. But notice this, it's been taught that if somebody asks for claims, do you want to review one? And the customer's like, I sure do. That one number 2, I'm really not happy with. So now the customer can say, I'd like a review of number 2. Here's my complaint about it. Now what happens? Well, instead of making the customer wait for something, we're going to say, look, we're going to investigate it immediately. And if everything runs right behind the scenes, we're going to do it very quickly in an asynchronous fashion. Well, how does that look? This is that second part of the claim review. Well, what do we do in the claim review? This is real-time intelligence using event streaming. Right here, what I'm going to do is take in and tell Event Stream, you take the source of that claims review table. This is where the reviews are coming in. Anytime you see a new one, you process it. What does processing look like? Well, in Event Stream, you can set what's called a custom endpoint, and that's what this looks like here. So what I'm going to do is take any new rows that come in for this review, I'm going to feed them through this endpoint, and I'm going to write a piece of code that listens to that endpoint and processes it. I wrote no code to make that happen. So what does that code look like? Well, this is where the data science comes in. Now again, notice this. We're getting in the review information. The review information includes keys to information in the OneLake, like the customer ID, et cetera, type things like that. So that if I only get the claim ID and the customer complaint, I can look up things like, I don't know, how much money this customer spends with me. What's their claim history? Information about the customer. And so I can write something like in PySpark. Now this is going to look complicated, but we'll kind of walk through it a little bit. So I'm going to use the new Azure AI functions that are built into Fabric, and I love this part. I did not deploy an AI model. I just use AI functions in Fabric to make this happen because models are already available to you in PySpark to make that work. So I want to use one of those models like I did before in the chat app, but this time I'm going to use it as an AI agent. So then I'm going to come through and I'm going to go connect to my Event Hub stream. This is me reading the stream. So this is going to run continuously in the background. Now this is where the beautiful part starts right here. I'm going to take the claim ID right here that came in from that review that I'm reading from the stream, and I'm going to go look up in OneLake, not affecting the operational database, information about the customer. Why am I going to do that? Because I'm going to scroll down here further, and here is where it gets nice. I'm going to send a prompt to the agent and tell it, hey, here's information about this that I need you to help me with as an agent. Here is input for you to go look at other tools in your disposal to make a recommendation for me. Maybe perhaps, for example, one of the tools is policies of the company are built in like PDF files somewhere. So the agent could take this input about the customer, look at policies that are available to it as a tool, and come back with a recommendation. So what do we do with this recommendation? We just throw it on a screen somewhere? No, this is the beautiful part. We write it back into OneLake. We can use PySpark to go write a Delta table back into OneLake so the recommendation appears like a table. Pretty cool. Now what does that look like? Well, here is what my lakehouse looks like. Notice here, I've got the mirrored data tables from SQL, but I've also got the recommendations. And it has keys to show it's related. So I've shown you the power of not just mirroring SQL data in a lakehouse, but also writing to the lakehouse the recommendations. Why would I do that? Because I could go build a semantic model on this. And why would I build a semantic model? Because I want to do this. I want to go write Power BI report. The Power BI report can now use OneLake without affecting the operational database and help this claims officer. So the report could look something like this. Now, I don't know if you've used this before, but I'm using something called the visual narrative in Power BI. If you've never tried this before, if you're not a Power BI person, I'm not. I tried it. You can stick inside your report a copilot. The copilot can automatically provide an executive summary of your report, and it dynamically changes as your data changes. That is incredibly cool. So I've stuck that at the top of this. And notice in the middle of the report is all the information about the customer. This is the beauty of going after OneLake. I'm looking at the customer information, their claim history, their premium spend, and the recommendations from the agent itself. So scrolling down here, I get all this rich information. So think of this now, a claims officer now at any point in time can go look at these reports and get information very quickly and recommendations from an agent how to help this customer. And then I can process these claim reviews faster using consistent policies from the company. Think about where we go past this thing. And if you look at this slide right here, think about this incredible summary. What if we use Activator in Fabric? That's something you can do to maybe do a Teams message to this officer. Hey, here's a very important customer the agent just detected. Maybe we should go spend time helping this person right now to prioritize my work. So if you think about all this solution together, it's all built into Fabric. It is connecting with Foundry inside Azure itself, but it's a very deep integrated solution. And this slide, in my mind, summarizes why do we do this? Why would you build a database inside Fabric? Because it's so easy to integrate all these solutions together. Now, Neetha, I'd like to come back on stage here because you and I were looking at this today a little bit in the speaker room, and I was showing this to you, and I was like, is there a way to make Cosmos be part of this story?
Absolutely, Bob. First of all, I want to say I was just watching this backstage
Yeah.
and I'm amazed.
It's pretty good stuff,
What a
right?
power in
Yeah,
Fabric,
I
and
know.
just as you said, what a power in data that fuels AI innovation.
Right.
So it's amazing to see this, end to end. And I want to show you how you can bring Cosmos DB data into this ecosystem.
Really?
Yeah. So here we have all the claims information, right? That's no non-structured JSON data, Bob. So hey, we have the claims information. So per claim, whether that's coming through claim officers or support staff or chat agents, now you can store that as nested data in Cosmos DB right there in Fabric and join that data with SQL, and let's see what they actually
Is it like
found.
a log then? So
Yeah,
it's
it's a
log,
totally.
which would be like JSON normally.
Yep, JSON
So it's
log.
sitting in Fabric. Okay, so what does it look like? Show it to me.
Absolutely. So
Okay.
here we have the claim data. As you can see, it is an interaction log through all the support staff and chat agents. This data is available in OneLake through SQL endpoint. And now we're going to look at the SQL DB SQL endpoint. So here you have your claims database. I just took over it, Bob, while you were not
You took over
watching.
my workspace, didn't you, Anita?
Yeah, I did. And you can see all of the tables there from
Oh.
SQL DB that you just showed, the claims
Okay.
table. I'm going to pull Cosmos DB in here. And
Because it's already there. I
It's
can
already
join
there,
together.
exactly.
Oh, okay. Are you
In
going
the
to join
same-
this together?
absolutely.
Okay.
Absolutely. So we have the claims data with SQL data, and we're going to put a query together. Now, as you can see, we are taking the claims and joining that with policies. And so where there are premium policies, they're looking for, are there any other claims that are open? Because they just had an escalation on this claim too.
Okay.
And they want to see if there are any other cases for this customer that are open. And they found another claim, a claim ID 4, that they need to watch out for. So they're now able to provide better service to their end customers and improve their reputation end to end.
So it's just a natural combination. In the claims main database was SQL driven, people are familiar with that. But then in this case, this log made perfect sense because it's already just JSON information. Why not just put it in Cosmos?
Yeah.
But because it's related data and it's all in this one lake, I can just join it together. I could even add to that Power BI report if necessary with this information.
Exactly.
Oh, that's pretty
Yep.
cool. That's actually cool. Well, let's kind of close it out today, Anita, I think a little bit. And make sure there's one thing you should be aware. Patrick LeBlanc is going to be so happy that I put this slide in here, right? So did you know that we announced here at Build that if you also love Power BI, there's ability to do write-backs. So something called translytical, yes, we invented a new word, translytical task flows. So in Power BI, you can make changes, write that back to a database like SQL Database and Fabric. This was super popular. You may have seen this demonstrated in the keynotes. Kind of excited to see where this is going to help developers even take this whole journey even further. So take a look at Translytical Task Flows public preview announced here. Anita, we love partners. I should do like partners. I mean, I love partners because it really leverages the message of what we're trying to do at Microsoft. You're going to be blown away, Anita. The partner team gave me this slide at FabCon in March. Twice as many now partners are then from March to today that
Wow.
shows up. And
That's
one of those
fantastic.
partners is Mac Software, who we really love talking to. So we talked to Mac before this event, and they said, you know what? We've got a pretty cool story with SQL Database and Fabric. We work with a company called Aptean. And this partner helped Aptean build a SQL Database and Fabric solution. I want you to look at that diagram and look at some of the bold letters. Integrated, fast, accelerated, all into an actual woven solution. This is a real world solution versus my insurance claim solution, where a company like Aptean is helping drive and getting more efficient because of the fact they use a database inside Fabric. Take a look at our partners. That slide's going to get so big we can't even put all the icons and all those customers on that slide. We really want you to get involved. In the Fabric community itself, SQL Database, Cosmos DB are now part of this community. It could be the Fabric community itself. It could be users group. There's something called super users now. That's a really great way to get initiated. If you've never been involved in Fabric before, you're a tried and true SQL Cosmos developer, we still want you to be involved with us in just pure databases, but being involved with Fabric, you know what that's going to do for you? That's going to light up all those solutions that we showed you today, because you may not see that where you are today in just Cosmos or SQL, but if you're in the Fabric community, you're going to start finding out, how do I become that part of that great integrated rich story? Now, as we said before, when we're done here, we're going to come down here and talk to you afterwards and answer your questions, but we want to give you some resources. So remember, the deck, AKA MS, Bob Ward MS, folder out there. The entire deck is there. If you want to go back on a Sunday and take a nap and listen to us go over these demos and stuff, you're welcome to do that. But all the demos, all the slides, all the information is in there. And then look at these great resources. You get started with either SQL DB and Fabric. Anita talked about signing up for the preview for Cosmos DB.
For now.
Did you know, have you ever seen the Fabric trial? It's crazy. What is it like? I forgot how much the value is. Arun told me one time what it is. You could go build an app with the Fabric trial, not just a POC, an actual app during that trial period, and really show off what it is possible to do this with databases. We've got some great learning series for you, some labs. I'm sure the Cosmos DB team will also be part of that story at some point. Don't forget about Data Exposed. We always are on there talking about incredible new technologies through small videos. And the Fabric Roadmap. The SQL database team just this week added their roadmap story to the Fabric roadmap overall, so you can see and keep track of across the entire Fabric ecosystem, what are we doing? What's the future look like? And the Cosmos DB team will also be joining that roadmap. Anita, it was a pleasure being with you today. I really appreciate your time.
Thank you so much, Bob. Same here, and I'm really honored to be on stage with you with an expert like you.
That was great.
I've learned a lot, an amazing demo. Hands for Bob for his amazing demo.
Well, thank you guys. Appreciate it. Thank you. We'll be down here afterwards to talk to you later. Thank you.